Matrix Pre-Calc. This is problem 6-94. It gives us this rational function m of x here, and it wants us to find the horizontal and vertical asymptotes and to graph it. So to find the horizontal asymptote, there are some rules, and I guess I'll go over those. But basically the rule is, think about if you put in a giant number for x on the top and the bottom, like everywhere you see an x, this the top would be 3 times bigger than the bottom. So the asymptote's going to end up being at 3. And I'll show you a guideline for that. I wrote it down here. With asymptotes, with horizontal asymptotes, if the numerator and the denominator have the same degree of x, like it's raised to the same power, then you just use the ratio of the coefficients. In our problem, they're both x, the highest degree is 1, so they're both first degree in the numerator and denominator, and the coefficient is 3 over 1, so that's 3. Sometimes you'll have the numerator, I wrote top and bottom for numerator and denominator. The top of the fraction will have like maybe x squared on it, but the bottom is just an x. That's has a degree where the numerator's greater, the degree is greater than the denominator, and those aren't going to have an asymptote because those are going to just explode as x gets large. Those are going to just tend up to infinity. Or if x gets small, I suppose they could, well, they're not going to have an asymptote anyway, not a horizontal asymptote. So, and then if the numerator is less than the denominator, then we'll tend to have an asymptote being the x-axis, or y equals 0. And that kind of makes sense because the bottom of the fraction is going to be getting really, really big, but the top isn't. The top's going to be small and the bottom's going to be big, and you know when you divide by a bigger number, your fraction gets smaller. So that's how I found the horizontal asymptote, is I looked at the degree and I saw that the degree is the same, and so I took the ratio of the coefficients and I got 3. And so what I do, I'm just going to add that to my graph. I just made a little dotted line at 3, at y equals 3. And then I want to find, it asked me for both of the asymptotes, but also I wanted to find the x and y intercepts because they asked me to graph it. But we'll look at the vertical asymptote next, since they asked for those. Vertical asymptote comes from whenever the denominator of a rational function is 0, so I set it equal to 0 and I got 4. So you just draw a vertical, like, dotted line. That's your asymptote. And then to help me draw the graph, I would like to know the x and y intercept. So x-intercept happens when y equals 0. And y, like if this is y, it's going to be 0 when that numerator zeroes out. So basically just take the numerator, set it equal to 0, and then you can find out what the x-intercept is. And I got 5/3, which is 1 2/3, so I just kind of marked it there on my graph. And then I got the y-intercept by plugging in, I actually did the math right here, I plugged in, wherever I saw an x, I plugged in a 0, and I ended up with 1 1/4. That's the y-intercept, so that's up here. And then I didn't really know how they go together, so I had to go back and look and ask myself about the end behavior. I know it's going to tend toward these asymptotes that we have here, and I know the graph has to go through the intercepts. So I just needed to know, is it here and here, or is it here and here? Well, I mean, it's kind of a giveaway. You kind of know this part's going to go down here. For this part, I just looked and I thought, well, what happens if x is like 100 or something? Well, that would be some big number, 300 minus 5. You can plug numbers in if you want to, but I see that this ratio is going to be positive, so I knew it's going to have to be, this branch has to be up here. And so that's how I got the graph, just by using end behavior. So then letter B, it's kind of the same thing, but I didn't I didn't do a very nice graph, but I did the same procedure. They want me to find the horizontal and the vertical asymptote. If I look for the horizontal asymptote, well, I'm going to look at the degree of the numerator and denominator. It's the same. So when the degree of the numerator and the denominator are the same, you use the ratio of the coefficients. So I'm getting 4. 4 over 1 is 4. So I can draw that in. I drew it really small. 1, 2, 3, 4. I drew it in. And then vertical asymptote comes from whenever the denominator equals 0. So I set the denominator equal to 0 and solved it. And when I unsquared, when I square rooted both sides, I had a plus or minus. So that's why square root 2, I think, is 1.41-ish. So I just kind of drew in my vertical asymptotes. And then I wanted to know what the x and y intercepts are. So for the x-intercept, I just basically, it's when that numerator is 0, that's when your whole fraction is going to be 0. So the easiest way to do this is just to set your numerator equal to 0. So I added 4 to both sides, divide by 4 on both sides, square root, and I got plus or minus 1. So that's so I had these two x-intercepts, and then the y-intercept happens when x equals 0. So I simply plugged in plugged in 0 for x. So I had 4 times 0 minus 4 gave me negative 4, and then 0 squared minus 2 gave me negative 2, and I divided and I got 2. So that was my y-intercept. 1, 2. So I put that in. And then that made me know, like, just because of these 3 intercepts, I knew that the graph had to go this way, down here. But then I have these other regions I needed to find out where the graph goes. So I just asked myself, you know, way out here when x is a really big number, is this ratio going to be positive? Like, because I really want to know, is it above the asymptote or below? So it's going to be positive. It's going to tend toward 4. So I knew this had to go up here like this. And then I look over here, and the same thing if I plug in some negative, like negative infinity. Well, when it gets squared out, it's going to turn it positive anyway, and this is also going to tend toward 4. So your graph will have these like 3 branches on it. And that's it.